Good afternoon, class. We are looking at section 8.4, polar coordinates, equations and graphs. So the objectives are to identify and graph polar equations by converting to rectangular equations, test polar equations for symmetry, graph polar equations by plotting points. Again, what you're looking at here is the synopsis of everything we've seen before, class. Unit circle, equation of circles. It's important we're going to need them. Sine law, cosine law, sum and difference formulas, even and odd properties, definition of sine and cosine, as far as a right triangle is concerned, and periodic functions, fundamental identities. For double angle and half angle, we have the summary here that comes from the double angle formulas. Half angle formulas. Product to sum and sum to product. This is the synopsis of what we have covered. You can find all these formulas in previous notes, and we're going to move on now. Polar coordinates. In a two-dimensional coordinate, this is extremely important to remember that. Each point on a plane is determined by rectangular coordinate x comma y, a distance from y and x-axis. Polar r comma theta, a distance from a reference point called the pole, and an angle from a reference direction called the polar axis. In other words, this is the pole and polar axis along the positive side of the x-axis. A point P has coordinates x comma y or r comma theta. And as we go from one format to the next, rectangular is x comma y, polar is r comma theta. And the relationship is that x squared plus y squared equals r squared. Tan theta is y over x, and you have to adjust it for the quadrant accordingly. Polar coordinate is in the form of r comma theta and can be represented infinitely many different ways as we add 2k pi. If we want to change the r to negative, we add pi or odd multiples of I. As always, k is an integer. So this is what we have seen. And now, polar equations and graphs. Rectangular and polar grid. Remember, here's the rectangular coordinate system. The polar grid, the way it works, you have the pole, you have the polar axis, and you draw circles, okay? Because when you have an angle of interest, for example, power 4, then you go one tick mark, okay? R is 1, theta is power 4. You go two tick marks, becomes 2 power 4. You go three tick marks, becomes a 3 power 4, 4 power 4. So let me just put them. So this one, 3 power 4, 4 power 4, 5 power 4. That's the way it works. If you look at this one, okay, we have the angle 5 power 4, and then we start counting 1, 2, 3, 4 tick marks. A polar equation of a curve is the one expressed in polar coordinates and written with r as a function of theta. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. This equation may demonstrate different forms of symmetry around the axis. So just the way we had symmetry here with respect to the x or y axis, we have them here too. Identifying and graphing polar equations. Reminding you x equals r cosine theta, y equals r sine theta, x squared plus y squared is r squared, tan theta is y over x. Now identify and graph the equation of r equals 3, convert to rectangular equation. We've seen this before. If we square both sides, r squared equals 3 squared or 9. So we replace the r squared with x squared plus y squared. And this is a circle with radius being 3, because as you recall, x squared plus y squared equals r squared, represents a circle centered at 0, 0. X minus h quantity squared plus y minus k quantity squared equals r squared represents a circle centered at h, comma, k. So what are we dealing with here? We are dealing with a circle with the radius of 3. And its center is at the pole. So it looks like that. So you just have a circle centered at the pole. Very straightforward, everybody. What about theta equals power 4? If you take tangent of both sides, tan of theta is tan of power 4, and we know tan of theta is y over x. We know tan of power 4 is 1. Tan of theta is y over x, tan of power 4 is 1. Therefore, the cross product will give you y equals x, and as you know, y equals x is a line through the origin. So theta equals power 4 or y equals x are the same. And everybody remembers this line. By the way, we have the x and y, okay, the rectangular grid as well as the uh, polar grid, okay? We have both of them. Rectangular coordinate system, polar coordinate system, or just grids. It's important to know that how they work. We are going to move on. We are just recognizing that when theta is any angle, it just represents a line through the origin. That's the idea. If theta is pi over 6, then it goes through the angle of pi over 6. That's the idea. If r equals 5, then circle with radius 5. So that's what we have learned so far. So y equals tan theta times x. Remember this one. If you do the cross product, the equation becomes y equals tan of theta times x. So that's how you go from polar to rectangular. What about r sine theta equals 2? I hope you recognize this one as y. Therefore, what is y equals 2? A horizontal line. So you know y equals 2 in a rectangular coordinate system. We have x and y, okay, class? In a rectangular coordinate system, that's what we have. So y equals 2 represents a horizontal line. How do you know that in polar format? R sine theta is some constant. R sine theta equals 5, y equals 5. R sine theta equals negative 1. Horizontal line y equals negative. What about r cosine theta? The same way, we know x is r cosine theta. So if r cosine theta is negative 3, that means x must be negative 3. And you know x equals a number is a vertical line. So x equals minus 3. So go 1, 2, 3, and we draw a vertical line. Very simple, class. Some of those you can go from one format to the next easily. Now we want to identify the graph of this one, r equals 4 sine theta. I hope you remember in the previous section, the technique was when you have r and sine or cosine involved, the technique is to multiply by r, multiply both sides by r. You do that, this becomes r squared, this becomes 4r sine theta. You replace the r squared with x squared plus y squared and 4r sine theta. 4r sine theta is y. And this takes us to a rectangular coordinate system. We know how to handle it by moving the 4y next to y squared. We recognize this as a circle, and we have to complete the square. This is fine. And this one, b is minus 4, divided by 2 is negative 2. Squared is positive 4. So add 4 to both sides. And what happens is, this remains the same thing. This one is the variable for the radius, which is y, and b over 2. It's negative 2, positive 2, whatever it is. So y minus 2 quantity squared. And so you compare that to this. Again, you're supposed to know that. Then you're dealing with a circle, which is centered at 0, 2. The radius is square root of 4 or 2. So x squared. So r equals 4 sine theta, and x squared plus y minus 2 quantity squared equals 4 are the same. This one, we recognize it as a circle centered at 0, 2, with the radius being 2. Zero, 2. The circle, it may not be to scale, but it's close enough. And that's your answer, and you're done. In the case of r equals minus 2 cosine theta, we want to convert it to rectangular equation. We use the same technique. If we have r and sine or cosine makes no difference, the technique is to multiply by both sides. This becomes r squared. This becomes negative 2r cosine theta. This is replaced with x squared plus y squared. My equals minus 2. R cosine theta is replaced with x. Now we are in business. We are going to move things around and work on that. So we're going to move the negative 2x next to x squared. And we're going to complete this square. This is b divided by 2. Square it. So we're going to add 1 to both sides. And what happens is, this is the variable of interest x, and b over 2, this is positive 1. So x plus 1 quantity squared. So this equation in polar format, this equation in rectangular format are the same. This one, we recognize it as a circle centered at negative 1, 0. Radius is square root of 1, which makes it 1. So we should have no problem with this recognition, everybody. So again, this is the combination of a rectangular coordinate system and the polar grid. So -1, 0, you go 1 to the left and you draw a circle with the radius 1. That's the idea. Okay, everybody? So what did we learn? Theorem. R equals a constant gives us a circle with the center at the pole and radius A. The radius is A. That's important to understand. So that's one thing we learned. Let's move on with the next thing that we learned. When theta is a number, a constant, then y equals tan of that, whatever the angle is, tan of that times x, which makes it a line which goes through the origin. When r sine theta is a constant, then y equals a. It's a horizontal line, everybody. When r cosine theta is a constant, then x equals a. It's a vertical line. So this is what we learned. What else did we learn? We are assuming a is positive. If r is 2a cosine theta or minus 2a cosine theta or 2a sine theta or minus 2a sine theta, if it involves that r and cosine or sine, it's a circle. Where is the center? In the case of a cosine, remember cosine corresponds to x, so it's along the x-axis. In this case, at a0, in this case, at minus a0. Sine corresponds to the y. In this case, the center is at 0a. In this case, it's at 0 minus a. All of them have the same r. Radius is the same for all of them. Radius is r. For all of it. So very straightforward. I hope everybody's okay with that. So that's what we learned. All right, let's discuss symmetry as we have seen it in rectangular coordinate system. The same thing here, symmetry. Symmetry with respect to WRT, remember, with respect to the polar axis, x-axis. If in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So take a look at this graph. This is theta, this is minus theta, r comma theta, r comma minus theta. Symmetry with respect to the line theta equals pi over 2. Remember, theta equals pi over 2 is really the y-axis, okay? So if the polar equation r comma theta can be replaced by r comma pi minus theta, the graph is symmetric with respect to the line theta equals power 2 or the y-axis. So over here, r comma theta. Over here, we have r comma pi minus theta. Symmetry with respect to the pole, the origin. If the polar equation r comma theta can be replaced either by this one, minus r comma theta, or r comma theta plus pi, the graph is symmetric with respect to the pole. So if we have r theta, we have also minus r theta or r comma theta plus pi. That means symmetric with respect to the pole. So pretty straightforward, everybody. All right, we want to graph r equals 1 minus sine theta. Let's see what happens. And as far as graphing, just like any other graph when we started, you just plot points and you can graph it. But we want to discuss the symmetry also because of the topic we just covered. So first and foremost, we are going to check the symmetry by replacing the theta with minus theta, which gives us symmetry with respect to the polar axis, the x-axis. Let's see what happens. So 1 minus sine of theta, we change it to minus theta. I'm looking at the first case, okay? And so what happens, class? As you know, sine is odd, this becomes minus, and this makes it plus. And no, that doesn't work. The test fails. Now we are going to go with the second case, and we are going to check with pi minus theta. That means we're going to replace the theta with pi minus theta. We expand this one as sine alpha cosine beta minus cosine alpha sine beta, sine pi cosine theta minus cosine pi sine theta. As you know, sine of pi is 0, cosine of pi is -1. Negative times negative makes it plus sine theta. With this negative, keeps it at negative. So these two are identical. Then the graph must be symmetric with respect to the line theta equals power 2. So this is identical to this, okay? The third one, let's replace the r with minus r. And if we multiply both sides by negative, this becomes minus, this becomes positive, and that's the same as the original one. No, that doesn't work. Also, you should check two things here. That's one of them. The other one, theta plus pi. So let's replace the theta with theta plus pi. And then we expand it just the way we did this one. It becomes almost the same thing with the plus sign. So cosine, sine theta, cosine pi, cosine theta sine pi, and put the negative sign outside. In other words, keep this negative outside. And so you know cosine is -1, and you know sine is 0. And so this, never mind, goes away. This becomes minus sine theta. This makes it positive. And so no, that doesn't work. So there's only one symmetry, and that's with respect to theta equals power 2. So the symmetry doesn't exist with respect to the first one and the second one, the polar axis or the pole or the origin. All right, and by the way, we're going to continue. We are going to graph this. This is looks like how they call it, cardioid. So how do you graph it? Just plot pairs. So And I'm going to go with easy ones that I don't need a calculator. For example, I know that theta is 0, then 1 minus 0, I get 1. Okay, so I want R 1 minus sine theta. If I put pi, so I get 1 here. If I put pi over 6, sine of pi over 6 is 1/2. 1 minus that is 1/2. Pi over 4, 1 minus square root of 2 over 2. Pi over 3, 1 minus square root of 3 over 2. Pi over 2, 1 minus sine of pi over 2 is 1, 0. 5 pi over 6, remember, is the same as pi over 6 because in the second quadrant sign is positive. So 1 minus 1/2 and it becomes 1/2. Pi, sine of pi is 0, I get 1. 7 pi over 6, I get 1 minus negative 1/2, gives me 3/2. Okay, 3 pi over 2, I get negative 1. 1 minus negative 1 gives me 2. 11 pi over 6 is the same as pi over 6, but negative. So 1 minus negative 1/2. Again, I get 3/2. 2 pi takes me back to 0 plus. And I write them as a pair. Okay. And we put some of them in there. Now, I'm not going to plot all of them. It's a good idea to do all of them because this one is square root of 2, for example. 1.41 divided by 2 is about 0.7. 1 minus that is about 0.3 roughly. So I'm going to go with the easy one, starting with the first one, 1, comma, 0. Remember, it's r theta. So it's along the 0 degree. And you go 1 tick mark. Okay. The next one is 1/2 pi over 6. So find pi over 6. And this is 1, go half of it, roughly, just to give you an idea of where we end up. I'm not going to deal with those. 0 pi over 2. Okay. And this is pi over 2, and 0 puts you back in the, pole. Next, I'm going to go with this one. Again, I'm finding easy numbers. 5 pi over 6 is here. And I'm going to go 1/2. If this is, we are assuming this is 1, this is 2, this is 3. This is really not to scale, but you get the picture. So if that's the case, so 1/2 is somewhere there. Okay. 1 pi, this is pi over 180 degrees. So 1 puts us here. Okay. 3 pi over 2. So 3 pi over 2 is down here. And 2 is 1 and 2 tick marks here. 3/2, 11 pi over 6. So 11 pi over 6 is this one, this angle. 3/2, so this is 1, this is 2, so in between. Okay. And now you graph this and put them all together, and it looks like that. So I hope you see how it's graphed, everybody. It's pretty straightforward. Now, notice the graph. The left half and the right half are the same, so symmetric with respect to the y-axis, theta equals pi over 2. All right, we want to graph r equals 1 plus sine theta. So I want to approach this differently because I want you to be exposed to various approaches of graphing. So r equals 1 plus sine theta in Cartesian coordinates. What is that? You know how to graph y equals sine theta and move it up by 1. Just, I'm going to, so this would be a complete cycle. Now move it up by 1 and it looks like that, right? Looks like that. So again, this is a different approach. At least you're exposed to it, and then you decide what approach you want to take. So read values of R corresponding to increasing values of theta stages in sketching the cardioid. R equals 1 plus sine theta. So what happens here? As we move from 0 to power 2, the y coordinate moves from 1 to 2. I hope you see that. As we move from 0 to power 2, the y coordinate moves from 1 to 2. Right? Plug in 0, you get 1. Plug in power 2, you get 2. Right? So as theta increases from 0 to power 2, R increases from 1 to 2. When theta is 0, R is 1. When theta is power 2, sine of power 2, 1 and 1 is 2. So look, so at theta equals 0, we are at 1. At theta equals power 2, we are at 2. So this is the motion. Of course, if you want more precise, pick power 6, power 4, power 3, and you see that power 6 would be easy because it's 1/2. So it gives you, at power 6, it gives you 1.5. Okay, 3/2. So that's the motion. What happens here? Remember 1, 2, 3, 4 arcs. So as we go from power 2 to pi, we go down from 2 to 1. As theta increases from pi over 2, so from pi over 2 to pi, R decreases from the maximum of 2 to 1. So theta is pi over 2, R is 2. Theta is pi, R is 1. So it moves like that. And again, you can find angles in between, such as 2 power 3, 5 power 6, and figure out what happens. So we are here, and now from pi to 3 power 2, as theta increases from pi to 3 power 2, from here to here. Maybe I do this. Let me. So this is the red part. This part, I'm going to call it 1. This is the second part. This is the third part. So as it moves from pi to 3 power 2, then R decreases from 1 to 0. So here's 1, here's 0. So it moves this way. I hope you see the concept now. So at theta equals pi, R is 1. If you put 3 power 2, okay, the sign is -1 with 1 becomes 0. So this would be the third stage. The final stage, as we go from 3 power 2 to 2 pi, this is the final stage. As we go from 3 power 2 to 2 pi, R increases from 0 to 1. So this is 1. So it increases from 0 to 1. Theta equals 3 pi over 2, R is 0. Theta equals 2 pi. This is 0, so we get 1. And this is the last stage. And why is this called a cardioid? Looks like a cardioid. So that means R equals 1 plus sine theta gives rise to a cardioid. Again, this is a different approach, everybody. Graph R equals 1 minus cosine theta. This is the grid. Again, cardioid. When R is A times 1 plus minus cosine theta, or A times 1 plus minus sine theta, and A is positive, passes through the pole. That's it, cardioid. And so we're going to put theta, r equals 1 minus cosine theta, r comma theta, and we're going to go with some easy numbers that we can do calculation in our head. Common arcs by that, I mean. If I put 0 here, cosine of 0 is 1. 1 minus 1 gives me 0. If I put pi over 6, 1 minus square root of 3 over 2. If I put pi over 4, 1 minus square root of 2 over 2. If I put pi over 3, 1 minus 1 half, I get 1 half. That's easy. If I put pi over 2, this is 0, I get 1. If I put 2 pi over 3, I get negative 1 half because cosine is negative in the second quadrant. 1 minus negative 1 half makes it 3 halves because 1 minus plus 1 half. And if I put pi, cosine is negative 1 minus negative 1 makes it plus 1, so they add up to 2. And those are the pairs. So we can put 0, 0 here. Again, I don't want to go with those. If I want to go with those, square root of 3 is about 1.7. Divided by 2 is about 0.85. 1 minus that is 0.50. I'm going to go with easy numbers. 1 half and pi over 3. We locate pi over 3 and 1 tick mark. One, two, three, four, 1 tick. Then I'm going to go with the easy one. Pi over 2 is this one, right? And I'm going to go with 1 tick mark. Uh, 1 tick mark is 1 half, so I'm going to go with 2 tick marks. Okay, so we are assuming 1 tick mark is 1 half, but this is a different scale. So we got those. And if we go pi, this is pi, we go 2 tick marks. So 1, 2, 3, 4 tick marks means 2. Okay. Okay, so, oh, that's 3 halves. 2 power 3, everybody. This is 3 halves. That was an easy one. I didn't notice it. That's an easy one. And now if you put them together, it looks like that. So that's that. What if we change the theta to minus theta? I want you to notice because cosine actually, remember, it's an even function. So r equals 1 minus cosine theta. And if I replace the theta with minus theta, I get the same function, which means it's symmetric with respect to the polar axis. That means now that I have this one, I can figure out the other half. You follow what I'm saying? Identical to this one with respect to the x-axis, flip it over. That's the meaning of it. Or if you want to just plot those pairs, for example, 4 pi over 3, if you put it, it's just the same as pi over 3, but negative. So it's negative 1 half with negative becomes positive. So 4 pi over 3 gives you 3 halves. Okay. 3 pi over 2 is 0. So that you have 5 pi over 3 gives you positive 1/2. 1 minus positive 1/2 is 1/2. 2 pi gives you positive 1. 1 minus 1 is 0. So those are the pairs, and this is the complete graph. So just do the same thing at the bottom. Okay. The same thing at the bottom. Graphing polar equations by plotting points. Here's the graph. Here's the equation. R equals 3 plus 2 cosine theta, reminding you of the symmetry. So you don't have to worry about that. Okay. Now let's quickly discuss the symmetry. You replace the theta with negative theta. A cosine is an even function. Nothing changes. And therefore, that means it's symmetric with respect to the polar axis. Let's replace it with pi minus theta and expand it. So this 3, this plus 2, and then the brackets cosine pi, cosine theta plus sine pi, sine theta, and we know that cosine pi is -1. This is 0, so that goes away. So this is minus cosine theta times 2 makes it minus. So 3 minus 2 cosine theta, there is no symmetry. The test fails here. Let's check it out with the third case. So we are going to replace the r with negative r. Again, just testing the symmetry for practice. And so we get minus r, but 3 plus 2 cosine theta, nothing happens. You can multiply both sides by negative. This becomes r, this becomes minus. Let's do that. Just if I multiply both sides by negative, I get r here, but I get minus 3 minus 2 cosine theta. That's why it fails. It doesn't work. Let's replace it with theta plus pi, and that doesn't work either. Just if you expand this, you get 2 times cosine theta cosine pi minus sine theta sine pi. Okay, if you expand it, sine pi is 0, you don't have to worry about it. Cosine pi is -1, makes this one negative, so that's not going to work out. Okay, so it becomes actually the same as this one, so that fails too, just in case. Now, so we know it's symmetric with respect to the polar axis. That means the top half and the bottom half are the same. You have an expectation. Now let's pick up again easy numbers. By easy, again, I mean something we can do it in our head. So if I plug in 0, cosine of 0 is 1, I get 2, and 3 is 5. If I put pi over 6, is the square root of 3 over 2 times 2 plus 3. If I put pi over 3, I get 1/2. 2 times that is 1, and 3 is 4. If I put pi over 2, this is 0, I get 3. If I put 2 pi over 3, it's -1/2 times 2. It's -1 with 3 is positive 2. 5 pi over 6 is the same as pi over 6 square root of 3 over 2, but negative. So 3 plus 2 times negative square root of 3 over 2. If I put pi here, I get -1. So plus 3 plus 2 times -1 makes it positive 1. So again, I'm assuming that's not a problem. These are approximations, these two. And those are the pairs. So take a look at the pairs. So the first one is 0, 5. And so if 1, 2, 3, 4, 5, 0, so that puts it here. Okay. Remember, first you go with the angle. Okay. I can do that with 4.73 roughly pi over 6 or 30 degrees and 4.73 just for the sake of argument 30 degrees. So this is 1, 2, 3, 4.73 somewhere here. But let's go with this easy one. 4 and power 3. Power 3 is 60 degrees, everybody. And we want 4. So let's go here and count. 1, 2, 3, 4. So somewhere there, roughly. 3 and power 2. Power 2 or 90 degrees. Let's count 1, 2, 3. Okay, 2 and 2 power 3. 2 power 3 is 120 degrees. 2 power 3. And we go with 2 tick marks here. Okay. If I want this one is about 1.27, so 5 power 6. That means 150 degrees and 1.27 is somewhere there. But let me go with the easy one. 1 comma pi. So going this way and 1 tick mark. So roughly there. And then the bottom is identical. So if you draw the top, the bottom is identical because of the symmetry. So here's the top portion, and here's the 2 points that I didn't do. 4.73 power 6, 1.7, 1.275 power 6. You can see that. Okay. And it's not exact, but you get the picture. And the bottom is here too. And the name is Limicon. Without an inner loop, because we do have a case of an inner loop also. All right. Now Limicon with an inner loop. A graph is R equals 2 plus 3 cosine theta. Okay. So now this number is actually less than that. If you go back to the previous one, was the other way around. This number was larger. That's the difference that it makes here. All right. First and foremost, quickly notice if I change the theta to negative theta, nothing changes. And so the symmetry does exist, okay? Because it's cosine. But anyways, let's go with easy numbers. Easy numbers, class 0, cosine is 1, 2, and 3 is 5. Pi over 6, square root of 3 over 2 times 3 plus 2. Pi over 4, square root of 2 over 2 times 3 plus 2. Pi over 3 is a good number, is easy. Pi over 3 is 1/2. So 3 times that, 3 halves and 2, 7 halves. Okay. Pi over 2 is a good number because this is 0, gives us 2. 2 pi over 3 is a good number because the answer is 1/2. And because it's in the second quadrant, -1. So the same as pi over 3. But the reason it's negative because in the second quadrant, cosine is negative in the second quadrant. So -1/2, you get -3/2 and 2, you get +1/2 here. Pi is a good number because that gives you -1, 2 plus 3 times -1, that gives you -1. 4 pi over 3 again is a good number, just like 2 pi over 3, you get -1/2 and the result is 1/2. 3 pi over 2, good number because you plug in, and 3 pi over 2 gives you 0, so that's just 2. 5 pi over 3 is a good number. It's just like pi over 3, and it's positive because in the fourth quadrant, cosine is positive, so it gives you +1/2 times 3, 3/2 and 2 is 7/2. 2 pi is a good number. It goes back to 0, 5. Okay. So those are the pair, those are the answers, and those are the pairs. Okay, everybody. As I mentioned, when you change the theta to minus theta, nothing happens. So that means it's symmetric with respect to the polar axis. So you have the top half and then just the bottom half is identical to that, right? And so let's plot easy points class, 5, 0. So this is 0. You go with the degree first and then 5, 1, 2, 3, 4, 5. I don't want to go with those. I want to go with easy ones. 7/2 and pi over 3. So pi over 3 is 60 degrees. Okay. 7/2, 3.5. So 1, 2, 3.5. Okay. Again, this one is pi over 2 is 90 degrees. And 2, 1 and 2 tick marks. So it goes like that, everybody. Okay. 2 and pi over 2. Now, 1/2, 2 pi over 3. So 2 pi over 3 is 120 degrees, and it's somewhere there. And then 1/2, I said -1 pi go to, okay, here's what happens here. Pi is here, everybody, 1. You have to go negative, so you go here. I hope you recognize that. By the way, note 2 plus 3 cosine theta equals to 0. Cosine theta equals -2/3. If you set that equal to 0, if you want R to be 0, okay. And therefore, theta is cosine inverse of -2/3, which is 2.301 radians. That means at some angle, it goes to the pole. That's the idea, class. Whenever R is 0, the angle could be anything. R is 0, the pole. If you're at the pole, you can represent it with R comma theta, where R is 0. When R is 0, theta can be any angle. It makes no difference. However, why am I mentioning this? At some point, it has to go back to that 0. It happened to be at this angle, 131.81 degrees roughly. So at once between these two, so somewhere here goes back to 0. So this goes back to 0. Okay. And then it loops because of this. Pay attention to the meaning of this, everybody. This one means what? This one means pi is this way. -1 takes you to the other side, this way. And again, we do have a point here as well. We do have the point there as well. Now 3 pi over 2 down here is at 2, so we go 1 and 2 tick marks. And so here's the graph, everybody. The graph goes like that. Let me just do it by hand. I will clean it up. So the graph goes like that, but it has to go back to 0 at this point. And it goes back. And it becomes like that. Now I'm going to make it look better in a moment, but that's the idea. And so if I erase my work, this is how it looks like. So it goes back to that. By the way, this does have, okay, cosine theta equals negative 2/3. This does have two answers. It goes back to 0 two times. Okay, this is one of it. Anyways. All right. Rows. Graph the equation R equals 2 cosine 2 theta. And again, reminding you of all the symmetry. We're going to try the symmetry, and then we're going to see how the graph looks like. We start with changing the theta to minus theta. As you know, cosine is even, so nothing happens. We get the same function, the same graph. Therefore, the test works, and it's symmetric with respect to the polar axis. The next thing, we change it to pi minus theta. And so we are changing the theta to pi minus theta. And that means 2 pi minus 2 theta. And because the cosine function is a periodic function with a period of 2 pi, this is the same as 2 cosine of minus 2 theta, right? Because the 2 pi, you can take it away, which makes it the same as 2 cosine 2 theta, and it's symmetric with respect to the y-axis. Theta equals pi over 2 is really the y-axis, right, class? But just theta equals pi over 2. And the pole. The function is symmetric with respect to the polar axis as well as the symmetric with theta equals pi over 2. That makes it symmetric with respect to the pole. If the first two work, this must work too. I leave it for you to show that. But if it is symmetric with respect to the polar axis and the y-axis or theta equals pi over 2, it's symmetric with respect to the pole as well. You can try this to see whether it works or not. And the way you try it is that you check both of them, okay? All right, let's plot points and see how that works. This becomes a rows. Theta, r equals 2 cosine 2 theta, or comma theta. Again, let's go with easy numbers. 0, that gives you cosine of 0. which is 1, times 2 makes it 2. Pi over 6. Pi over 6, 2 times pi over 6 is pi over 3, cosine is 1/2, 2 times that is 1. Pi over 4, 2 times that is pi. Cosine of pi is -1, and that gives us negative 2 times -1, -2. Pi over 3 gives us 2 pi over 3. 2 pi over 3 is the same as pi over 3, but it's negative. So -1/2. 2 times -1/2 is -1. Pi over 2 times 2 is pi. And for pi is -1. 2 times -1 is -2. I'm sorry, pi over 4 is times 2 is pi over 2, and cosine of pi over 2 is 0. So this is what we get. These are the pairs. So one more time, quickly. If you put 0, cosine of 0 is 1, times 2 is 2. If you put pi over 6, times 2 becomes pi over 3. Pi over 3 cosine is 1/2. If you put pi over 4, gives you pi over 2. Cosine of pi over 2 is 0. If you put pi over 3, it gives you 2 pi over 3. And that gives you -1/2 times 2. If you put pi over 2, gives you pi. Cosine is -1. Those are the pairs. So if we plot those, for example, 2, 0. So this is the 0 degree, and you go 1 and 2, tick marks. Pi over 6 is 30 degrees, and we go 1, tick mark. Okay, there. 0 and pi over 4. Pi over 4 is 45 degrees in between, and we get 0. Oh, this is interesting. I didn't notice the 0. When R is 0, it doesn't matter what you have, class 0, okay, pole, has coordinates 0 with any theta. I mentioned it last time. Any angle, it doesn't matter, the R is 0. -1 pi over 3. So pi over 3 is 60 degrees. So we are in this direction. Because it's -1, we go in the opposite direction. Okay, so again, pi over 3 is 60 degrees. And the reason we go in the negative direction, because -2. Again, -1. Pi over 2, the same thing. It's in the positive direction, but this negative takes us down by 2. So that's only from 0 to pi over 2 class. Okay. Now you go from pi over 2 to pi, then from pi to 3 pi over 2, then from 3 pi over 2 to 2 pi, and you notice it looks like that. If you put your graph in polar format and plug in this one, the graph looks like that. I will show you quickly in a moment as far as this is concerned with a graphing utility. But let me give you the synopsis of what we just found. Rose curves are characterized by equations of the form r equals a plus cosine n theta, or r equals a sine n theta, and a can't be 0, and have graphs that are rose shaped. If n is not equal to 0 is even, the rose has 2 n petals. If n is not equal to plus minus 1 is odd, the rose has n petals. So if it's odd, for example, cosine of 3 theta or sine of 3 theta. On the other hand, as we saw in the previous page, cosine of 2 theta, 2 end up giving us 4 petals. Lemniscates are characterized by equation of the form r squared equals a squared sine 2 theta. r squared equals a squared cosine 2 theta, where a is not equal to 0, and have graphs that are propeller shaped. So this is the synopsis of some of the stuff that are important for you to see. I want to quickly show you this graph thing by going over this, and let me see if I can. Okay, so you put this on. First class, let's clear everything. You have to go to the mode and make sure it's in polar form. So I'm going to bring it down so you can see that function polar. You have to make sure it's polar form. Then you put the y here, and you put r equals 2 cosine 2 theta. And if you graph it now, maybe I should, because I want to show you, if I clear it and graph it. No, okay, so let me do this. Let me, okay, so let me put now 2 cosine 2 theta, close parentheses, enter, and now let me graph. Notice. So I hope you see that the graphing calculators can do the job, but you have to have an idea roughly how the graph looks like.